All right, this is question number 15 of the worksheet connected particles. Some part of the figure got cut while cut pasting it from the worksheet, so I've just drawn it here. Okay, the question says each of the three light strings has a particle attached to one of its end. Okay, now these are three strings. First string, so it will have a tension of its own. Second string will have a tension of its own. And the third string will have a tension of its own because these are three different strings. Okay, let's say this tension is T1 upwards. So let's call this T2 first. Okay, this would be T1. Oh, I want it right in purple. Okay, this is T1. And T1 will be equals to the weight W1 of this particle. T2 will be equals to the weight W2 of the particle, and T3 would be equals to the weight, which is 5 newtons. So we know T1 equals W1 since the system is in equilibrium, and T2 equals W2, and T3 equals 5 newtons. Okay. The strings are in equilibrium with two of them passing over fixed smooth horizontal pegs and with the particles hanging freely, and weights of the particle and the angles between the sloping parts of the strings and the vertical are shown in the diagram. Find the value of W1 and W2. Okay. Now looking at A, this is going to be T1 as well, which is actually W1. And this is going to be T2, which is actually W2. I'm going to apply Lemmy's theorem on this setup. Okay, so I'll start with T1. Instead of T1, I'm writing W1 over sine of the opposite angle. This would be 180 minus 60, which would be 120. So we write sine 120 equals to, we have a 5 Newton force, this one. So 5 upon sine of opposite angle, this would be 100. So sine 100 equals to the third force, which is this one, W2 upon sine of the opposite angle. This is 180 minus 40, which is sine 140. Now you can solve this and this, get W1, which should come out to be 4.40. Then you solve these two and get W2, which comes out to be 3.26 newtons. And that's how you do question 15 using Lemmy's theorem.